Find the concentration of total solids in milligrams per liter. In this problem, 200 milliliters of a raw sample of water is poured through a pre-weighed filter paper. The filter paper is then dried and weighed, with the filterable solids remaining on the paper. Water that passes through the filter paper is collected for the second test, where 100 milliliters of the filtered water is poured into a pre-weighed dish. The dish is then dried out and weighed again, with the solid residue remaining in the dish. The concentration of total solids equals the concentration of filterable solids, which can be determined from the first test, plus the concentration of non-filterable solids, which can be determined from the second test. The concentration of the filterable solids equals the mass of the solid material retained on the filter divided by the volume of the sample tested. Although we don't have a measurement for the mass of the filtered solids, we can determine this mass by subtracting the mass of the filter from the mass of the filter plus solids. Plugging in the masses and volume, the concentration of filterable solids equals 0.00103 grams per milliliter. Converting this concentration to milligrams per liter, the filterable solids concentration equals 1030 milligrams per liter. The concentration of non-filterable solids is calculated the same way, by dividing the mass of the solid residue, which passes through the filter, by the volume of the sample tested. As before, the mass of the dried residue is equivalent to the mass of the dish plus the dried residue minus the mass of the dish. Plugging in the masses and volume, the concentration of non-filterable solids equals 0.00808 grams per milliliter. Converting the concentration to the proper units, as we did before, the concentration of non-filterable solids equals 8,080 milligrams per liter. By knowing the concentrations for both the filterable solids and the non-filterable solids, these quantities are plugged into the equation, and the concentration of total solids equals 9,110 milligrams per liter. When reviewing the possible solutions, the answer is D.